In this machining tutorial, we're going to look at the steps to create the toolpaths for the part that you can see in front of you. This is a fairly large sign, it's about 36 inches across, the piece of material there. So we're going to go through the similar steps that we've been through in the other machining tutorials, that is to create the border vectors, to do the offsets we need, to create the area that we're going to do the 3D carving in. We're going to generate a roughing, finishing toolpath. This time though we're going to add a V-carving toolpath that's going to be projected onto the banner to do the text. Finally we'll do a cutout pass, and that'll finish up this particular example. So let's minimize our image, go into the Aspire software. File we're going to open is on the tutorials CD under the folder 13 machining, under the subfolder files, and in here we've got a file called Mac2 Heron Sign Start. So make sure you open the one with the word start in it. Now this essentially is the sign that we created earlier, exactly at the stage that we finished it off. So if we just go up to View, tile the windows horizontal so we can see it in the 2D and the 3D view. If you've watched this tutorial, you'll remember the last few things that we did were to change the colours of the image in order to be able to save it out for presentation. Also in this example, we modelled the lettering onto the banner. For this example that we're going to cut though, we're actually going to take that lettering and we're going to V-carve it into the top of the banner instead. That's going to be more efficient to cut and give us a lot sharper lettering than if we went back and forward over 3D lettering at the size that that's at. So there's a few things we need to do to get this ready. First thing, if we pop open the component manager by hitting F8, is we need to take our component group and we want to ungroup it. This is going to do a couple of things. If we look in the 3D view, it appears that everything's gone a little bit strange now. And that's because a lot of the components are actually set to merge, and by ungrouping it they've been put at the bottom of the list, so they're now merging into our main base shape. So one thing we can do is just move the base shape to the bottom. The colour is no longer an issue for me, so it doesn't matter, it just has to be in the right order to get the part ready for machining. I'm also going to come in here and undraw the text, so I don't want that component to be available to me. When we create a toolpath, it will only cut the components that are currently visible. So by turning that component off, in effect it's not going to be included when we create the toolpaths. However, I haven't had to delete it in case I needed it for a future operation. So the part looks correct and is ready for me to start applying toolpaths to it. If we hide the component manager, a couple of other things I need to do to prepare is to make sure I have all the vectors I need for the toolpaths I'm going to be creating. In this case I have the text which I'm going to V-carve, so I don't need to do anything with that. And also in the modelling part of the process we actually created a vector around the outside of the job, so that's already in place for me to do my cutout pass. What it would be nice to do though is to offset that outwards, because if you remember, what I need to do when I'm cutting with a ball nose cutter on a finish cut is to make sure that the boundary is a bit bigger than the size of the part. That way it'll allow the edge of the tool to roll over the part and not leave any kind of a lip. In this case I'm going to finish cut this with a 1/4 inch ball nose cutter, so I can offset this out anywhere up to the radius of that tool to get it to roll over without rolling all the way down to the back plane. So what we're going to do is come over to the edit vectors. With that vector selected, I'm going to offset it outwards by 0.1, and that's going to create a second vector. If we zoom in, we can see that there following around the outside of our part. At this point in time we're ready to start to go in and do the machining for the part. So let's hit F12 to go over to the toolpath list and set up the material. When I click on the material here, you can see it's set for 1.5" thick material, and that's good. I'm going to use 1.5" thick HDU foam, high density urethane foam, typically used in the sign industry. My part is actually 1¼ inches thick, roughly, so that leaves me with a little extra material, so I can leave some material at the top, and that also leaves me some material at the bottom as well to reinforce the whole part. If I wanted to be more precise about this depth, I could go back, take the components and scale them, or use this scale model function. In this case I'm happy with how that is, it fits inside my material. The last couple of things I'm going to do is set my rapid clearance gap and my home position, and I'm going to hit OK on there, and we're ready to now start creating the toolpaths. First toolpath we're going to create is a roughing pass, so we're going to select the outer of the two vectors, the one that we offset, so I can zoom in there to make sure I've got the correct one. We can go to the 3D roughing, and this time I'm going to select a pretty large bit. I'm going to select a 1/2 inch end mill in order to hog out this material. I'm going to check the machining allowance. 30 thousandths of an inch is good for that. That's the extra thickness it's going to leave on for the finish cut. And this time I'm going to choose to do a Z-level strategy. That means that it's actually going to cut in 2D layers, but taking into account the 3D area. So in effect it's like a whole bunch of area clearances that hog out the material, leaving the 3D part intact. How many passes I get is going to be determined by the pass depth I've got set for that tool. So in this case, let's just set it to a fairly low depth for that tool in this material, but just so that when we create the toolpath we're going to see a lot of examples of layers within the toolpath. So I'm going to select a pass depth of 0.3, which means every 0.3 of an inch as it goes through this material there's going to be a roughing cut if there's material to clear out. So the boundary's selected. I've set up all my parameters. If I needed to, I could change the name, and I can hit calculate. And there is my toolpath in the 3D view. If we want, we can also preview that under the preview menu, and we can see that starting to be hogged out and clearing away the material, so we're ready to go in there with a finish cutter. For the finish cut, we're going to use the same boundary. Remember, we need it to be offset to allow for the tool to roll down, and from the tool database I'm going to select a 1/4 inch ball nose cutter, 0.25 inch, and all the parameters look pretty good in there. Remember, for a good finish cut you want to be somewhere between 8 and 15% on the step over, so 10% is a good value. I can hit OK, and here I can choose whether I want to do an offset strategy or a raster. In the first machining example we did a raster strategy, so we can see something a little different here. We'll choose the offset and hit calculate. In cutting foam it really doesn't matter. One of the reasons for choosing a raster strategy might be that you want to cut along or across the grain depending on the type of material you're cutting. In foam it's irrelevant because there is no grain, so an offset strategy is going to be fine for that. There's my toolpath, looks very dense. If we want to preview that, we'll actually see that animating on the screen. And at the moment you can see I've got the animate preview and draw tool options set, which means that you can actually see a little tool being animated as the materials cut away. If I wanted to speed this simulation up, I could uncheck both of those and it would just jump straight to the stage of the part being simulated when I did this simulation for the toolpath. The next operation is to do the V-carving for the text on the banner. So with the text selected, we can come over to the V-carving toolpath under the toolpath operations. There are really two ways to approach cutting this. The banner surface is below the top of my material, so my start depth is not going to be 0. Now I can either look at the banner here, and you can see as I run the cursor over the top of the banner, if you look in the bottom right hand corner of the window, it's displaying the X, Y and Z position of that. So I can see the depth of the banner is at 0.101 inches below the top of the material. So if I wanted to, I could set that as the start depth. However, in Aspire I have an option where I can just project the toolpath onto the 3D model. What this does, even if the model has got a little bit of curvature, is take the toolpath and project it down onto the surface, so I don't need to actually figure out what that depth is. I just need to select my tool. In this case we'll use a 90° V-bit. Make sure the project is set up, hit calculate, and what that's going to do is calculate my V-carve toolpath but project it down onto the surface of the banner. Really the best way to check what the result of that is to do the preview, and there we can see the text has been nicely V-carved into the surface of my banner. In this case my banner is pretty much flat, but this would even work on very slight curvatures as well. The final operation here is to do a cutout pass around the outside of the job. So I'm going to come in here and select the vector that's on the inside of the inside of the one that we offset there. Zoom out the 3D a little so we can see what's happening. We'll come over to the profile, create profile toolpath. I want to make sure I've got a value set to cut all the way through the material, 1.5 in this case, and I could just go ahead and say that I want to machine vectors on the outside and hit calculate. Now that's going to calculate a number of passes based on whatever the pass depth was for the tool. If we double click on the toolpath again, I can hit edit, and I can see we've got it set to 1/2 inch passes in this foam material, and so it's going to take 3 passes to cut all the way through. There are quite a few other options when you're doing profile toolpaths, and really you should consult the reference manual for a detailed description of how they all work. One handy one though, if you don't have, say, a vacuum hold down system or another way of keeping the part in place, is to tab it to the waste material. What this option does, if we come down to the tabs and check that on, is to actually let me build little areas that are going to be left attached to our waste material after the part has been cut out. So what that means is the part will be held in place, and once you're done cutting you can remove those by hand or using some kind of hand tools. You basically set up the length and thickness that you want these to be. In this case we might set it a little thicker in order to see them. We can click on edit tabs, and that gives me the ability to add tabs in the 2D view, or I could just specify a constant number. It's also possible for me to interactively move these to make sure they're in places that are going to be easy for me to clean up once the part's removed, and also that are going to hold the part in place. So you can see the location of our 6 tabs where those yellow T's are. If I hit close and calculate, it's now going to generate toolpath with those tabs built in. And if we preview that cutout toolpath and tip the part up, I may need to zoom in a bit to see them, but you can see there's a tab down the bottom here, there's a tab over here, and then we have tabs in the other places where we specified they should be, and that should hold the part in place and allow me to keep it there even if I don't have vacuum hold down or another way of keeping it still. At any time after you've calculated a toolpath that you decide that you might want to change the parameters of it, you can just go to the list and double click the toolpath, and that will bring up the original menu. For instance, if we wanted to go back to the profile toolpath here and decide after all that we didn't want tabs, we can just uncheck it, hit calculate. If I preview that, we'll see that it's going to cut all the way through now. We can actually maximize that in the 3D view, delete the waste material, and there's the part that we're actually going to cut when we run these toolpaths. Once again, if we were going to save these now, we just hit the Save Toolpath option and choose the appropriate post-processors. If you want to see more information about saving the toolpaths, then make sure you view the machining tutorial number 1 that comes with the Aspire software. That concludes this particular machining demonstration. Mainly we recovered some of the things we've looked at in the earlier tutorials. That is, how to create the boundaries, how to do the offset to make sure you've got the boundary for the 3D, the roughing, the finishing, and then in this case what we also added was a V-carving toolpath that was projected onto our 3D surface. Finally, we did a cutout toolpath, looking at a couple of different options that we can use there in order to hold the part in place. And here we've just previewed everything, deleted the waste material, and we can see the finished part on there, and make sure that with the tooling we've selected and with the parameters that we've set up, that it's going to be an acceptable finish for us. If we looked at this and decided for whatever reason it wasn't acceptable, then we need to think about what changes we need to make, whether we need smaller tooling or whether we need to enlarge or deepen a part, change the angle of the bit we're using for the text or something like that, and make those changes before you actually commit to saving the toolpaths and sending them to your machine. And that concludes this particular tutorial.